Hit it, Grace!
It's time for Maths with Mr. Thomas.
Hey, we have made it to the start of a brand new chapter. This is chapter 8, Scientific Notation. I've split this across 3 lessons, and then included some past paper exam questions and a review exercise or lesson just at the end. But we're starting off with what scientific notation is and converting to scientific notation. First of all, there is another name for scientific notation. Does anybody know it? Go on then, what is it, James? Standard form! You're perfectly right. Yes, scientific notation is also known as standard form. And what is it used for?
It was used if you're like a scientist as a way of writing really big numbers or really small numbers as an easy way of understanding them.
Yeah, you're perfectly right. Well done, Kevin. Good, that is what it is. And it's an easy way of writing really big or small numbers by using powers of 10 instead of just strings of zeros. For example, if we took the weight of something really heavy,
My car!
heavier than your car,
My house!
heavier than your house. Let's go with something like planet Earth. If we take the weight of planet Earth, the answer is that many grams.
Whoa!
I know, it's a lot. What is that number? Exactly. It's difficult to read when it's written like that. Or if we took something that was really small. My pencil, smaller than your pencil. My brain, smaller than that. If we took it like 1 hydrogen atom. What is the weight of a hydrogen atom?
I don't know.
Well, this is the weight of a hydrogen atom. It is that many grams, 0.166 grams. What's that number?
0.0000000.
Nobody's listening. It's because it's difficult to understand when it's written like that. But if we use powers of 10, we can make the numbers easier to understand. So let's look at some powers of 10. Let's say we have 10 to the power of 3. What is 10 to the power of 3? Abdul?
1,000.
It is 1,000. Good, because it's 10 times 10 times 10, which is 1,000. 10 squared, everybody knows that. It is 100. Good. 10 to the power of 1 is just 10. 10 to the power of 0. Anybody know 10 to the power of 0?
Oh, anything to the power of 0 is just 1.
Well done. Good. Let's have 10 to the power of negative 1 then. What's 10 to the power of negative 1?
You could write that as 1 over 10 to the power of positive 1, which will be 1 over 10, and 1 divided by 10 is 0.1.
Good, well done, it is 0.1. Or if you look at this pattern, we've got 1,000 to 100, so we've divided by 10, then we've divided by 10 to get 10, then we divided by 10 to get 1. Really, we're just dividing by 10 each time.
Oh, that means the next few are dead easy.
They are, good. What's the next one going to be then?
Well, we just divide by 10 again.
So 0.1 divided by 10 gives you 0.01. Good. And the next one, 10 to the power of negative 3. Yeah, you've got it. 0.001. What we can do is we can use these powers to rewrite some longer numbers. I'm not going to use a really long number. I'm going to use just a fairly small number just to give you the idea. But let's say we had something like 5,000. It's probably easier just to write it as 5,000, but this just gives you an example. 5,000. Well, it's 5,000. So in other words, it's 5 times by 1,000. But what you can do with it is you can rewrite that using powers of 10. So 5,000, it's 5, it's 1,000. So really, it's going to be 5 times by. But how do you write 1,000 using a power of 10?
Oh, that's just 1,000's 10 to the power of 3. So it's 5 times 10 to the power of 3.
Yeah, well done, Samantha. That is right. Well done. Okay, let's try another one. Let's say you had 6,200,000. How could you write that a different way?
You could have it as 6.2 million.
Yeah, so it's 6.2 times by a million. Brilliant. Again, rewrite it a different way. So the 6.2 you can leave as 6.2, but how do you write a million as a power of 10? Does anybody know what that would be? Yes. What are you thinking, Arthur? Oh, you're right. Yes, it is 10 to the power of 6. So you could write 6,200,000 as 6.2 million, and then a million is 10 to the power of 6, so it's 6.2 times 10 to the power of 6. That is what we're going to be doing. So, first of all, to write a number in scientific notation, I will show you these examples, and then I've got some questions just over here. But the way you do it is, first of all, put a decimal point after the first digit that is not a 0. Then what you do is you count how many places you need to move that decimal point to get back to the original number. So, let's try this then. Example 1, we have 450. So what do we do first?
Put a decimal point after the first digit so it's not a 0. So you get 4 point.
Good, so we get 4 point. What we then do is we list the other numbers up until it's just zeros. We don't bother writing them, so we'd have 4.5. So the decimal goes just after that first digit that's not a 0, so 4.5. What we then do is we write that using a power of 10. So we put times 10 to the power of, and we need to work out what this index is going to be here. Notice I am saying that if it's a large number, like 450, then you use a positive power, use a positive index. And if it's a small number, so if you get 0 point something, then you use a negative power. So what you want to do is you want to think, right, well, you put that, let me just get the pen, we put the decimal just after that 4, so we had 4.5, and to get back to the 450, well, 450 is the same as 450.0, so decimal's really there, so it means we'd have to then move it 2 places, which means we'd have to the power of 2. Woohoo! With 1,880. Again, the decimal goes after the first number that's not a 0, so we'd have 1 point. After that, list the other numbers up until it's just zeros. So we've got an 8, then an 8, then a 0, so we've got the 8, then the 8. And then what you do is you'd have times 10 to the power of, and again, you're working out this index. So if the decimal was after the first digit, if you had 1 point, well, just now, 1,880 is the same as 1,880.0, so you'd have to move the decimal 1, 2, 3 places, so we'd have times 10 to the power of 3.
Oh, that's that easy.
It is indeed, yes. With the next one, 503,000, how do you do that?
Put the decimal after the first number that's not a 0, so you'd have 5 point.
You would indeed, yes, you'd have 5 point. Then what do you do?
List the other numbers up until it's just zeros.
Good. So you've got a 0, 3 and then zeros. So we'd write down that 0, 3, so we're at 5.03. Then it's times 10 to the power of, and we need to work out what that index is going to be. So if we're putting this decimal just after the 5, if we were putting it in here, we would then have to move it back 1, 2, 3, 4, 5 places to get back to the original number, to get back to where it is. So it's times 10 to the power of 5. Woo! With D, 12,000, how do you do that? Good, the decimal would go after the first number, after the first digit. So you'd have 1.2. Good, because your decimal goes after the first digit, and then you list the other numbers up until it's just zeros. And then you think, how many places would you move that decimal to get back to where it is? And just now 12,000 is the same as 12,000.0, so really the decimal's there. And if we put it after the 1, you'd have to move it back 1, 2, 3, 4 places. So you'd have 1.2 times 10 to the power of 4. Woo! Hopefully that is making sense. Try some of these questions just on your own. Pause this video and then I will give you the answer. But for each one of them, you want to write the numbers in scientific notation. And remember, follow those steps. Put the decimal point after the first number that is not a 0. So you'd have 3.9. And then think how many places you would have to move that decimal to get back to the original number. You can pause it now. Okay, here we go. Here are the answers. Let's see how you did. Ba-doink! Mark them, see how you are doing. That is the answers for all of these. Hopefully you have managed them. If there's any you're unsure about, go back, have another wee look, ask your teacher. Don't cry. Okay, so now you have hopefully mastered the large numbers. Let's look at small numbers. What do we do with small numbers? Well, it's the exact same thing. It's the same idea. Decimal point still goes after the first digit that's not a 0. Then we still count how many places we need to move the decimal back to get the original number. However, because it's small numbers, because they're all 0 point, the index, the power, becomes a negative this time because we'll be moving the decimal back the way. So, with this one here, 0.00416, first number that's not a 0. What's first number that's not a 0? 4. Good. So we'd have a 4 point. And then what we do is we list the other numbers up until it's just zeros. So we'd have 4.16. 6. Then we put times 10 to the power of, and we have to work out what the index is going to be this time. So if the decimal was after the 4, if we had it just in here, to get back to its original place, you'd have to move it back 1, 2, 3 places. And that is the decimal right there. You can see it. And to get from there after the 4 back to that place, we had to go back 3 places. And because we're going back the way, because it's a small number, the index is a negative. So we've got times 10 to the power of negative 3. Next one, 0.00067. So for this one, once again, the decimal goes after the first digit that's not a 0. And the first digit that's not a 0 is the 6. So we've got 6 point. After that, we've got a 7 after it, so we'd write that 7 and then put times 10 to the power of, and we work out what that index is going to be. And if the decimal was in here after the 6, we would have to move the decimal back 1, 2, 3, 4 places to get to where it is just now. 1, 2, 3, 4, and because we moved it back the way, the index is negative 4. It is negative 4. Good. Next one, 0.0405000.
Once again, it's the same thing. You put the decimal after the first number that's not a 0.
Good. So the first number that's not a 0 is what?
It's the 4.
Good. So we've got 4 point, and then what?
Well, we've got 05000. So would you put the 05?
You do. You put the 05, yeah, because after that is just zeros. You'd ignore the bits that are just zeros, but we've got a 4 and then a 05, so we put in the 4.05. We have to include that 0. Don't suddenly change it to 4.5. Put it as 4.05. It's the zeros on the end that you can ignore. After that, if the decimal was after the 4, the decimal would be just here. But how many places do we have to move it back to its original position? You're moving it back 2 places. Good. So the index, the times 10 to the power of, becomes negative 2. It is. Well done. 4.05 times 10 to the power of negative 2. For D, 0.8, how would you do that one?
Well, the decimal goes after the first number that's not a 0. So that's the 8.
Good. So you'd have 8 point. And then if the decimal was after that, how many places would you have to move it back to the original position?
1.
Good. So you'd have 8 point. Well, I said 8 point. 8 point what? What's after that?
There's nothing there.
Good. So you can either write it down as 8.0 if you want, or you could just write it as 8. 8 works as well, because 8.0 is the same as 8. But if you had the decimal just after that 8, how many places do you move it back? 1. Good. And because you move it back the way, you would have times 10 to the power of negative 1. Good. So you can either write 8 times 10 to the power of negative 1 or 8.0 times 10 to the power of negative 1. Both answers would be absolutely fine. I would tend to go with that one though, because 8 is easier to write than 8.0. Okay, so that is how you do it with smaller numbers. Just remember, you need the negative power, the negative index. Try these questions just on your own. See how you get on with these. I will give you the answers in just a moment. Pause the video though. Pause it, and good luck. Here we go. So, how did you do it with each of these? It is the same idea. You had to just put a decimal after the first number that's not a 0, so I would have that as 7 point, and then you would think how many places to move it back. Moving it back 2, so you'd have 7 times 10 to the power of negative 2. That is the answer to A, and that's the answer to all the others. Check them, see how you got on with that. There's the questions, there are the answers. Hopefully you managed that. You did? Hey, good luck. Well done. Okay, so now you have mastered converting to scientific notation, you may wish to move on to the next video, or if you're wanting some practice, there are additional questions. There's some in the TJ Int 1 book, or various other textbooks. See how we get on with it. Best of luck. Woo! Have fun. See you in the next video. Bye!